Here is a brief video that will relate Avogadro's law to reactions of gases at the same temperature and pressure. Now we have to remember that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules. What that means is that if, say, 3 moles of one gas react with 1 mole of another gas, then at the same temperature and pressure, we measure that, 3 liters of the first gas will react with 1 liter of the second gas. So the mole ratio and the volume ratio are the same. Now you may recall that 1 volume of hydrogen will react with 1 volume of chlorine at the same temperature and pressure. So we infer that 1 molecule of hydrogen reacts with 1 volume of chlorine. If that doesn't make perfect sense, go ahead and revisit the video Gases and How They Combine. In that case, since mole is just a big number of molecules, then 1 mole of hydrogen would react with 1 mole of chlorine. Let's give a problem. Hydrogen reacts with chlorine in this way. 1 mole of hydrogen reacts with 1 mole of chlorine to form 2 moles of hydrogen chloride gas. Now, we have to remember that if it's at the same temperature and pressure, the mole ratio and the volume ratio are the same. So the problem is, if measured at the same temperature and pressure, how many milliliters of hydrogen gas will react with 52.5 milliliters of chlorine gas? Now we know that since the volume would be measured at the same temperature and pressure, that 52.5 milliliters of chlorine gas contains the same number of molecules as 52.5 milliliters of hydrogen gas. 1 volume of hydrogen reacts with 1 volume of chlorine. So we set up our equation this way. Question mark milliliters of hydrogen, that's what we're looking for, equals 52.5 milliliters of chlorine times the ratio 1 milliliter of hydrogen gas over 1 milliliter of chlorine gas, since 1 milliliter of each will react at the same temperature and pressure. When we do that, milliliters of chlorines cancel out, and we're left with 52.5 milliliters of hydrogen gas. Let's look at another question with a different ratio. Hydrogen reacts with oxygen in this way. 2 moles of hydrogen react with 1 mole of oxygen, that's the meaning of the 2 and the 1 coefficient, to form 2 moles of water, steam. If it's measured at the same temperature and pressure, we ask how many milliliters of hydrogen gas will react with 14.6 milliliters of oxygen gas. Now the equation tells us that 2 volumes of hydrogen react with 1 volume of oxygen because, if they're at the same temperature and pressure, that's true, because 2 moles of hydrogen react with 1 mole of oxygen. So we set up our equation like this. Question mark milliliters of hydrogen equals 14.6, the given milliliters of oxygen, times the ratio 2 milliliters of hydrogen over 1 milliliter of oxygen. The ratio of hydrogen to oxygen is 2 to 1. When we make that happen, the milliliters of oxygen over milliliters of oxygen is 1. It cancels out. We're left with 29.2 milliliters of hydrogen gas. This is how you solve problems involving volumes of gases reacting at the same temperature and pressure, often called volume-volume problems.